mga ka-learners, Teacher Angel here. Welcome back to Lesson 2 of our discussion on area. In computing the area, it is very important to identify the figure or object. There are three types of figures: planar figures, irregular planar figures, and solids. The area of each type of figure is computed using a different formula. After studying this lesson, you should be able to identify different planar figures and irregular solids. Use the appropriate formula in computing the area of planar figures, solids, and irregular planar figures, and solve for the area of planar figures, irregular planar figures, and solids. Area of planar figure. Before solving for the area of a figure, it is important to know if the figure is a planar figure, a solid, or an irregular planar figure. The areas of planar figures, solid, and irregular planar figures are computed based on different formulas. Planar figures have flat level surfaces. They include the square, rectangle, triangle, rhombus, and circle. Irregular planar figures, on the other hand, are made up of planar figures. How about solid figures? A solid figure has thickness and is thus said to have 3 dimensions. The following are the formulas for determining the area of different planar figures. For a triangle, its area is computed using the formula area of a triangle equals b times h all over 2, where b is the base of the triangle and h is the height of the triangle. To get the area of a square, you multiply the length of a side by itself. That's area of square equals s times s, or area of square equals s squared, when written down, where s is the side of a square. For a rectangle, you multiply its length by its width to get the area. The formula is as follows. Area of a rectangle equals L times W, where L is the length or the longer side of the rectangle and W is the width or the shorter side of the rectangle. For a rhombus, you need to measure the length of its diagonals and multiply them, then divide it by 2 to get the area. That's area of a rhombus equals D1 times D2 all over 2, where D1 and D2 are the lengths of a diagonal or the distance between the two opposite points of a rhombus. Finally, a circle's area is solved using the formula area of a circle equals pi times r squared, where r stands for the radius of the circle and pi as 3.14. Let's have a bit of practice in getting the area of planar figures. Try out these examples. Example 1. Look at this figure and try to solve the problem. A farmland shaped like the figure shown measures 600 meters on one side. If the recommended concentration of fertilizer to be used on the land is 30 kilograms per hectare, compute the total amount of fertilizer to be used. Make sure you identify the facts before we apply the formula. For this problem, we are given the length of the side of a square. To get the area, we use the area of a square, which is simply multiplying the length we have by itself. That's A equals 600 meters quantity squared. Solving for A, we get 360,000 square meters. Now, we convert the area in square meters to hectares. We multiply 360,000 square meters by the conversion factor 1 hectare over 10,000 square meters. Solving, we get 36 hectares. We can now compute the amount of fertilizer to be used for the farmland. That's 36 hectares multiplied by 30 kilogram per 1 hectare. Solving, we get 1,080 kilogram of fertilizer. Example 2. A rice field shaped like a rectangle has a length of 4,000 meters and a width of 1,000 meters. If the recommended number of seedlings to be planted per hectare is 10,000, what is the number of seedlings needed to plant the whole area? Let's go through the same steps we did in our first example. To start, let's find the area of the rectangular rice field. That's area equals length times width. Substituting the values, we get area equals 4,000 meters times 1,000 meters. Solving for area, we get 4 million square meters. Now, we convert our measurement to hectares. That's 4 million square meters multiplied by 1 hectare over 10,000 square meters or 400 hectares. We can now get the number of seedlings needed to use in the whole area. Simply multiply 400 hectares by 10,000 seedlings per hectare to get 4 million seedlings. Example 3. A triangular piece of plyboard has a base of 42 inches and a height of 56 inches. What is its area? For this problem, we are given both base or bottom part of a triangle and the height of a triangle. Using our formula, area equals base times height over 2, and plugging our values, we get area equals 42 inches times 56 inches over 2. That's area equals 2,352 square inches over 2, which gives us the area of the triangle 1,176 square inches. Example 4. A circular cake has radius of 6 inches. What is the area of the top part of the cake? Though we are only given one value, that is enough to solve the problem. Why? Because we are solving for the area of a circle. Remember that the area of a circle is equal to pi times r squared. We simply plug in the value of r, which is 6 inches, to the formula, since pi has a constant value of approximately 3.14. Doing so, we now have the following. Area equals 3.14 times 6 squared. Solving for area, we get area equals 3.14 times 36 square inches. So the area is 113.04 square inches. This means that the area of the top part of the cake is 113.04 square inches. Sit tight mga ka-learners!